Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this thinking word problem based on the concepts of vector addition. So as per the problem, three unit vectors m, n and p all lie in the same plane. The angle between vectors m and n is 60 degrees and the angle between vectors m and p is 30 degrees and n and p are perpendicular. So we have to draw vector x which is equal to m plus 2n minus 3p and determine its magnitude. So we have to find the magnitude of vector x. So the first step here is to draw the three given unit vectors. So first we should draw vectors n and p because it's easy to visualize them because they are perpendicular to each other. So let's assume this is vector n, and now vector p is perpendicular to this vector. So let's assume this is vector p. Now we are given that all three of them are unit vectors. That means they all have the same magnitude. So when we draw them, they should have the same length. Now we are given that the angle between vector m and n is 60 degrees and m and p is 30 degrees. So 60 degrees plus 30 degrees is 90 degrees. That means vector m is in between these two vectors. So vector m should be somewhere here. So same length as the other two vectors. So this angle here is 60 degrees. And this other angle here is 30 degrees. Now we have to draw vector x, which is a sum of these three vectors. So m, 2n and minus 3p. So for that we'll draw a separate vector diagram. So the first vector is vector m. So we have to draw a vector which has the same magnitude, same direction as the vector m we just drew. Now we have to draw vector 2n. Now 2n vector is double the length of this vector n, so it will be 2 units long and have the same direction, so it will be vertically up but double the length of the vector n. So this is vector 2n. So vector 3p will be 3 times the vector p but in the opposite direction because of the negative sign. So vector 3p can be drawn something like this. So 3 times the length of vector p. And it's going in the opposite direction. So in this diagram, vector x can be drawn as the fourth side in this quadrilateral. So it will go from the tail of vector m to the tip of vector 3p. So this vector here is vector x. And we have to find the magnitude of this vector. We are given that these three vectors are unit vectors m, n and p. That means the magnitude of n is equal to the magnitude of vector m is equal to the magnitude of vector p, which is equal to 1. So that means that the magnitude of vector 2n is equal to 2. That means this side length represented by vector 2n is 2 units long and the magnitude of vector 3p is equal to 3 units. So we'll use these as the side lengths to find the length of the side represented by vector x because we just have to find its magnitude. So we are done with the first part of the problem where we have to draw vector x. Now let's analyze this diagram. Now we know that vectors n and p are perpendicular to each other. That means vectors 2n and 3p are also perpendicular to each other, because the only thing we have done is to change the size of the vectors. We haven't changed their directions. So that means vector 2n and 3p are perpendicular to each other. Now we are given that the angle between vector m and n is 60 degrees. Now we haven't changed the direction of the vectors m and n to find vectors m and 2n in this diagram. So that means this angle here is equal to 60 degrees, because we cannot change the direction of these vectors. Otherwise, vector m won't stay vector m if we change its direction, and same for vector n. That means this angle here is equal to 120 degrees, because these are supplementary angles. Now we have to break up this quadrilateral into triangles. So first we can find this side here, which is the sum of vectors 2n and 3p. We cannot combine these three vectors together in one step, so that's why we have to break up this diagram into triangles. So the easiest triangle we can get here is this right angle triangle, because the angle between vectors n and p is a right angle. So this side here represents vector 2n minus 3p. And yeah, sorry, I should put that negative sign here, right? So this is minus 3p. This side represents 2n minus 3p. So first we should find the magnitude of this side. Now since it's a right angle triangle, we can use Pythagorean theorem. So let's assume the magnitude of this side length is y. We can write so y squared, because it's the hypotenuse, equals the magnitude of minus 3p squared plus magnitude of 2n squared. So we are using Pythagorean theorem. So we get y squared equals, so we know the magnitude of vector 3p is 3, so it will be 3 squared plus 2 squared. And if we square and add the numbers, we get y squared equals 13. We apply square root to both sides because we have to change y squared to just y. So the square root and the square cancel each other out, so we get y equals square root of 13. So that's the magnitude of this blue side. Now we have to find this blue angle here, because we know this black angle here in total is 120 degrees. So if we find this blue angle, then we can find this angle here, which is part of this smaller triangle, which we can then use to find the magnitude of vector x. So for that we can use tan ratio. So we can write tan theta equals, so the formula for tan is opposite over adjacent as per SOHCAHTOA. So it will be magnitude of minus 3p over the magnitude of 2n. So which is equal to 3 over 2. And now we can solve for theta by doing the inverse of tan. From that, so I got 56.3 degrees. So this should be the value of this blue angle. So that means the value of this black angle here in this smaller triangle. So that will be 120 degrees minus 56.3 degrees. So I got 63.7 degrees. We have to analyze this smaller triangle to find the magnitude of vector x. So this angle here is 63.7 degrees. Now in this triangle, we know this side length represented by y, we know the magnitude of vector m, and we know the angle between these two side lengths. So that means this is a case of SAS. So we can use cosine law to find the length of the side represented by vector x. So we can start with the general equation of cosine law. So the equation is a square equals b square plus c square minus 2bc times cosine of angle A. So A will be the magnitude of vector x equals, now the magnitude of side y, we found it to be square root of 13 square plus, now the other side represented by vector m is just 1 unit long because m is a unit vector. So plus 1 square minus 2 times square root of 13 times 1 times cosine of 63.7 degrees, because that's the angle opposite to vector x. Now we have to evaluate this expression. So we can do that on the side. So we get x square equals, so that's 13 plus 1 minus 3.195. Now we can combine these terms. So the magnitude of vector x square, so I got 10.805. And now we can apply square root to both sides. So the square and the square root on the left side cancel each other out, and we get the magnitude of vector x 3.29 units. So this should be the final answer for this problem. So I've rounded the answer to 2 decimal places. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.